Well, thank you again, everybody. Kia ora, everyone. Welcome today to the Space for Planet Earth Challenge 2023, Leveraging Satellite Data to Address Climate Change. We are announcing and convening for the first time our challenge participants from 5 countries in the Pacific region. They'll be participating in the Challenge Online Research Incubator starting next month. So also, I wanted to also note that we are also proud to be hosting this event as part of the Auckland Climate Festival, which has been going on for the month of September. So it's a citywide month full of climate action. So we're really happy that you're participating today because you're a part of the wider Auckland Climate Festival community, amongst others who share your vision and hope for a safe and just climate future. This year's festival theme is Nga Hua Awai, which encourages us to consider how our relationship with the natural world can strengthen our climate response. To find other opportunities to accelerate climate action across the end of the month online via the Auckland Climate Festival program. So also to start with, I wanted to thank our sponsors and our partners, of which without them, this competition would not have been made possible. So our partners and our sponsors have been helping out either with funding to promoting and also evaluating the applications for the last month. So again, just to note, our program today is like in 2 parts. So first, we're going to have a special presentation from Orbica on their geospatial analysis platform. And we're really excited because this platform is the one that the teams are actually going to be using during the incubator. And then we'll end with introducing the challenge incubator teams who are actually present today.
Yeah, so the challenge this time, as you know, is we're focusing, well, the challenge statement is using satellite data in combination with other data sources help develop scientific methods to identify target areas of methane emissions on Earth. And so I think all the teams are recognize the importance of methane emissions, which has been identified as one of the most cost-effective ways to control climate change and global warming. So with the incubator that has been set up will be running from October through November, and then after a break, we'll start again in January and February next year. And we'll have a whole series of webinar sessions and introduction to analysis tools and platform and access to different satellite data and mentorship and advice to the teams as we go along. A key part of this particular challenge is support from Orbica and Amazon Web Services for enabling geospatial analysis and also using cloud computing services, AWS in the background. And we'll be hearing more about that. So today with Orbica, we have Kurt Janssen, the CEO, and Santosh Seshadri, head of technology. Kurt is a geographer and geospatialist. He has a bachelor's with honors in geography from the University of Canterbury, and he worked for the New Zealand central government in the Ministry of Health and the Ministry of the Environment as a GIS advisor. He also worked for private companies in New Zealand and the United States, such as Esri and Albi and Orbiviz, and he established Orbica in 2017.
And I just wanted to point out that this month's Space-Based podcast in September is actually featuring Kurt as well. So go to spacebase.buzzsprout.com to listen to that episode.
And Santosh is a geospatial innovator and involving geodatabase development, geoprocessing techniques, use of Global Positioning System and Geographic Information System for data collection and applications. He has a bachelor's in mathematics, a minor in geophysics, and a master's in economics and GIS. And so, yeah, if we could turn things over to Kurt and Santosh. Oh, we need to unmute and
sounds good.
we need to highlight.
Just get this screen sharing. Right, we got there. Can someone just say they can see the screen?
Seeing the other screen.
Yes, we can, but I think you're in presenter mode.
How do I tell it to flip? There's something in Zoom, isn't there? Is that the one?
Yeah.
Did that work?
Yeah.
Okay, cool.
Oh.
It might be in the display settings up on top.
Oh, display settings, yeah.
Swap, there we go. Got it.
There you go.
Good.
Fantastic. Thanks, team. Great to be here. Awesome to be part of this this challenge. It's fantastic and super aligned to what Santosh and myself and the team are up to here at Orbica. So without further ado, I'll kick into a few slides, but then I'll hand off to Santosh, where we'll actually just give a little bit of flavor inside the platform using big data, geospatial data, space data, and crack into it. So something we're really passionate about, and sort of the core problem we're trying to solve, is there's tons of data in the world, and increasingly so. I just did a quick Google before to figure out the current Earth observation satellites, how many there are right now. And there's lots of them, as we can see, you know, over 1,000 active up there at present. And this is ever increasing with democratization of space and launch. And we're very much focused in this downstream space. How do we enable many folks to be able to leverage this data, find value in the data, and actually help decision makers make robust decisions about looking after the planet and the people, and leaving it in a better place, honestly, going forward. So I've talked a bit about satellites there, but remember, it's the broader aerospace as well, right? From drones and planes as well. And there's interesting initiatives happening in the stratosphere as well. All of these are data collection platforms, and it's all about now, what do we do with this data? How do we pull it together? How do we integrate it and actually build solutions to the global challenges we're facing? Simplistically, and we use this quite a bit, GIS, geospatial, location intelligence, they're all sort of bandied around. I just think about geospatial tech, geospatial data as the glue to tie all this stuff together, right? How do we optimize and understand and measure the world, the blue marble on which we live, its scarce resource, and how humans are using it for better or worse? It's that geospatial data, the ability to layer many information data sets and derived analyses from all these information sources, which drives the outcomes and the sort of the science about a data-driven approach to making better decisions, whether that's wildfire risk, whether that's sea level change, whether that's urban development and the loss of hinterland that's productive for growing vegetables. All of these things can be answered with data that exists right now, let alone new sources that are coming. And the location is simply that ability to layer it together and join it together, but like a common ID between tables and databases is a good way to think about it. If we evolve that and really think about this in your challenges too and what you're looking to achieve, we've done a lot of, over the years, static analyses, which leads to inactive decision-making, right? It's analysis based on data that happened in the past, which means that, hey, this event happened 6 months ago. And, if we think about Cyclone Gabrielle and the flooding up north and the impacts of that, we need these things in present data, which drives reactive decision-making, right? So I can't make an operational decision from an emergency management perspective on data that's 6 months old. So we need to leverage real-time algorithms, near real-time data capture to actually help inform decisions, the situational awareness of a problem statement to drive that decision-making now when we can actually have an impact. Now we extend that into the future. We'll touch on that a little bit in a moment. Where we really want to get is proactive decision-making. So how are we understanding right now the scenarios and the risks associated with things on the planet and human use of it? And how do we use past and historical data to inform and predict the scenarios of the future, i.e. be proactive? So now we're not waiting for the event to happen or the outcome to happen. We can predict with some certainty it's going to happen. So what does that mean in terms of how we respond and prepare for that and get ready for it? So this time element is just as vital in terms of the thinking around what you're trying to achieve and how it truly can have impact and scale in the world to make the place a better place. Now, on that note, I'm going to flick over to Santosh. I wanted to keep this short and sharp, and we'll go and have a look at some data inside the platform and run some analyses live, just to give a flavour of what's possible. This is not a deep dive by any means. You guys will get that ability in a few weeks when it kicks off proper. So Santosh, I'll pass over to you. I'll stop sharing.
Cool.
Just
All right, yeah. Can you guys see my screen? Cool.
Yes, we can.
Yeah. So this is the platform. So when we provision the platform, you guys will all have a login. And once you log in, it'll be kind of an empty space where we can now start spinning up kind of tools and services in the platform. So here, when you log in, we've got the documentation and the settings here, so you can invite users within your project that you want to bring in. You can just come here and add a user, and you can bring them onto the project. As an admin here, you'll be able to kind of provision additional services within your platform, and I'll come to what those services mean here in a minute. Within the organization, you'll have various workspaces, so you can create kind of different workspaces on how you want to organize your projects, organize your work. And within workspaces is where we have a project. So when we go into a project, here we've got a few options. So for example, when you come into a project and you click on a solution, you can add three main things within the platform. So the data store gives you the database, it gives you an API, and it gives you tile and feature services. So any spatial data that you import into a database, it will be available as an API and as a tile service. You can give it a password, which locks that database down, and only whoever has the access key can access that particular data. The analytics is a Jupyter Lab environment. So it'll deploy a Jupyter Lab within your project. It'll connect it to the database if it's already there, and you can also provide it how big you want a particular resource to be to run your particular analysis piece. And lastly, the custom solution. So for example, if you have already developed any apps like front-end apps or analysis or APIs, then you can Dockerize them and bring them on the platform. Provide us your Docker URL and we'll deploy within the platform. I'll just show you how all of that works here in a minute. So if I go into a project, let's say you've deployed a data store, what you essentially get is a Hasura tile server and a feature server. Just quickly, I'll just run through what these mean. So this will, when you push that deploy button within 5 minutes to 7 minutes, it will deploy this. And you can see that you have all the data sets within your database here that you can then access to write SQL or write other kind of queries against them. Not only can you write queries, you can also access that data via an API. So you can send a query to that particular request, to the particular URL, and request the query, and you'll get the response back. So all of that is already pre-built. All you have to do is import the data, and the APIs are immediately available. The next piece is the tile server. So this gives us the vector tile services of all of the data sets that's within the platform. So here's a data set, for example, that's the Queensland districts that I've imported into the database, and now it's available as a tile service, which you can then use that URL to bring into any other mapping tool that you want to bring into. So now we'll go into some analysis. So I'll go into my Jupyter Lab that's been deployed. I'm going to just do a simple remote sensing example to show you how all of those different pieces that I talked about earlier, like the database, the tile server, and the feature server, how they all work in sync in here. So here I've got a simple script which does some simple remote sensing here. So let's say we are interested in this area. I'm going to just draw a box in this area here. And let's say we want to go back to 2019 and get some Sentinel-2 imagery. And we are interested in these 4 bands. Sorry? Oh, sorry, I just did the whole year there. Let me just it might take about 5 to 10 minutes to get a whole year. So I'll just, for time purposes, I'll just do a smaller time period. So I'll just do 2019 and I'll do just maybe 1 month. And draw a box, I'll import. So what we've done and what you'll get as part of the platform as well is we've indexed all of New Zealand's Sentinel-2 data. We can also provide the access to stack interface from Australia as well. So you have the Australian imagery access within the platform. So you can just do the same thing. You can draw a box, select what parameters you want, what time frames you want, and get that data within your own analytical environment. And once it comes in, you can start doing any kind of spatial and remote sensing analysis on top of that. So what we're going to do here, I'm going to send this box into the platform and send this time period for 1 month, pick something that's 10 meter per pixel resolution, 10% cloud cover, and any data that's got these 4 bands, and that will return back the data that we need. So it's gone ahead and it said, okay, I've got 6 images that match your time period, but only 4 of them meet the criteria of 10% cloud cover. So then it's going to just bring that image. If you imagine, if you were to do this locally, you'd have to go to ESA or USGS Earth Explorer to download the actual raw tiles and perform the analysis on your local desktop. But all of those tools are available within the platform. So once it's going to load in, what we're going to calculate are simple things like NDVI that gives us the vegetation index, enhanced vegetation index, leaf area index, moisture index, and soil adjusted vegetation index. This notebook is just here to show you an example of what indices can be calculated. We're also going to provide the actual way to calculate these indices. So you can then, for example, I can go in here and you can see how each of these indices are calculated, and you can update that code based on whatever you're trying to do with your data set. So for example, here in NDVI, we're taking the near infrared, subtracting the red, and then dividing it by near infrared and red. But based on whatever index that you want to do within your challenge, you can calculate that and provide that within here. Once that's done, we can run the indices, and that will then give us the actual index. It's taking a bit longer here. While that's coming in, I can also do a quick example of another data set, which is the NetCDF data. So as you know, a lot of environmental data sets, a lot of your sensor data comes as NetCDF format. So we can come in here, and here all I'm going to do is import a NetCDF file that I have sitting locally on the platform here, but that could be sitting on an S3 bucket, could be sitting anywhere. As long as you have access to that NetCDF file, you can then just pass that and then consume that and interrogate the data, do some analysis. So here, for example, I passed in a lat long. It's giving me a time series plot of the sea surface temperature for the particular location. I can also say, give me multiple plots for different time periods for that same data. And then let's say we are interested in picking out areas that are above, let's say 290 Kelvin. That will then pick out the areas that are above that Kelvin, above that temperature. And it also provides you the tile service of that particular area. So you can then consume that into any other mapping application that you want to build on top. Let's see if this is done. That's done that. So now we've got our 4 images, and it's now gone ahead and calculated the NDVI for that area. As you can see, that's the area that we picked, and it's calculated our NDVI here. So darker the green, healthier the vegetation, browner, no vegetation there. And same thing with the moisture, brighter the color is where the water is, and darker the color, less water. We can then say, let me pick out all of the areas that are above a 0.7 index on NDVI, and I'll call this NDVI demo space challenge and run that within here. So it's gone ahead and picked out all the areas that are above 0.70, and I can even store that as a 0.70 file. Cool. So now, let's say we want to access that in an application. Now that data set is now available as a tile service. Let's say we want to do an additional analysis, but I want to say, oh, let me pick out all the areas that are above 0.9. I want to call the table 0.9 here, run that. It's going to give you a smaller subset of the data, and we can view that as a layer as well. There it is. These are all the areas that have an NDVI of 0.9 or above. We can do the same with NDMI. Let's say we want to pick out the moisture indices, and moisture goes between minus 0.25. So I can see here, minus 0.25 NDMI, and I'll call this 25 and run that. So there it's picked out the riverbed, and we can then save that and view that as a map as well. The next thing I'm going to do is I'm going to import some files that are coming in the Open Data Portal. So I've got a data set here from Canterbury Maps. In this example, I'm just pulling in the wells data and the catchments data that's available within the Open Data Portal. I'm just going to consume that particular data set. I'm going to load that into the platform, and we can then use that for analysis. Cool. It's inserted the wells data into the platform. It's inserted the catchments as well. So now we can view the wells within the platform here. So here are all the wells, and here are all the attributes that come with the well as well. So not only have we got the geometry, we've also got the additional attributes that come with that data. The catchments are also available. So here is the Canterbury water catchments with the additional attributes as well. Now, once it's in here, we can now start doing additional analysis. So I can bring that data in within my mapping interface within my Jupyter. So I can do additional analysis, or I can extract the data just for Christchurch. For example, here in this example, I'm just passing it a bounding box, and I'm passing it the layer name. And now it's going to just export that as a GeoJSON and bring that into my map here underneath. So here it is, and here it's got the pop-up for the data as well. Now, let's say we want to interpolate the well depth from that particular data set. I'm just using the depth attribute and interpolating just a simple surface based on that particular data. I can turn off my scatter plot, and we can just see just the interpolated surface here as well. So now that we've brought in 3 or 4 different data sets, what I'm going to show is we have a simple map viewer. So like I said, in the custom solution, you can pretty much deploy any app. So let's say you build a basic web map using Leaflet or Mapbox or any kind of technology. You can Dockerize that particular application, bring that into the platform, and you can view the results. So here in this map viewer, they're going to bring in the layers that we just created. So let's say I brought in the catchments, I brought in the wells, and here's my space challenge demos. Here's my NDVI of 0.7, 0.9, and here is my NDMI demo here. Sorry, not this one here, NDMI, and load those data sets. Cool. So we brought in everything in here, put the wells on top. So here are all of our wells that we just saw earlier that we brought in, and here are all the associated attributes with them. We can turn that off. We can look at the catchments. So here are the catchments information. We can turn that off. Here is our NDVI. So if I turn these off, let's turn on the NDVI 0.9, and there's the NDVI 0.7. And you can see by overlaying them what differences there are. You can also, in my example, you can kind of change colors and things, but that's totally up to the end user on how they want to build their maps. So the platform has all the tools and capability for you guys to kind of consume any data that you want, bring it in, process, analyze, store, and visualize them within the platform. So you can build an app and deploy it on the platform, share this link URL with anybody you want. Anybody else can then hit that map, see the results, and explore your analysis. So, yes, that's the kind of a general gist of the demo.
Awesome. Emmeline, that's sort of what we've got. Happy to take questions or for you to take back over, really. And I hope that was useful.
Yeah, no, thank you so much. I know that it's a whirlwind and it's a pretty fast. So I hope the teams are not scared but it's also the fact that there's just so much power in the platform as well that they're going to be able to potentially understand and use when we do a more extensive orientation during the incubator. So just in case, are there any burning questions from anybody? If you have any questions, just put it on the chat.
And just on that, Emmeline, I mean, it might look scary and we know it was a fast take, we didn't have long, but it's all open languages. It's just Python, it's R. So just ask ChatGPT to write some Python code, put it in the platform, configure it. I mean, there's a lot of open science out there, right? The algorithms we showed just now, that's just open science. They're available indices, and then you customize them for what the teams are trying to achieve. So once you get into it, the hard stuff is taken away. The tooling, the infrastructure, the version control of 50 libraries under the hood, so you can get on with it and solve your problem.
Yeah.
Yeah, and we'll have more details in October 17th and 19th are going to be scheduled for more in-depth training on this.
Yeah, for the teams.
For the teams. And each team will get their account and be able to build up. I really like the way that you can get something working and then you can build onto it in these notebooks as a working device.
Yeah, one key thing to think about, and as the team sort of think about things, is data. There's a lot of data in the world, so obviously we've indexed some stuff. So that would be one key thing is as the teams are thinking about different data sets that exist, how we can help them get some connectivity to the different data sets. We've got all the Sentinel-2, I know NASA's coming, there's a bunch of stuff we've got that works. But yeah, someone just mentioned it there, something about Sentinel-2. So yes, that's the sort of stuff I think we need to get some feedback on to just help you guys and the teams get access to data quicker.
Yeah, so there's two questions here. Well, one was that will they have access to Orbica platform, and if so, for how long? Yes, and that's for the duration of the incubator, and we'll talk about that in the next orientation sessions. And then there's a question on will there be other data sets like Sentinel-5P on the platform?
So we are right now working through and indexing all of Sentinel-2. If Sentinel-5P is available in the open data buckets, then you can definitely connect to that and index that as well if you want. So that's something that it's possible to bring it in. We just need to look at where the data is actually available.
All right.
Yeah. And the other thing will be country by country. So obviously we'll build a stack index for New Zealand because it doesn't exist here. Australia's already got one that we can dive straight into. All of Africa's got one. So again, it'll just be understanding different countries and just seeing what's already available we can hook into, or if we have to build something, or the teams actually build something.
Yeah, and also the platform already has the Open Data Cube and Stack tools available. So if Sentinel-5P is available as a Stack catalog, then you can just connect to the Stack catalog and download the images as needed. Yeah.
Very cool. Great. Again, thank you so much, Kurt and Santosh. This is really amazing, and your support really kicks the challenge to a whole new level in terms of what the capabilities are. So really thankful for it. I think we'll probably end this session on the Orbica stuff, and then we'll move on to the introductions of the teams, which we're really also pretty excited about. So let me just go back to my slide again. All right. So I know that some of the teams, unfortunately, are not online. Some of them have classes or have already meetings that were prearranged before this. But we are gonna hear from most of them. And so let's go with first, just to note that basically what happened was during the month of September, we had a set of evaluators from different countries, all the way from New Zealand, Australia, and, New Caledonia, US, and so forth, that actually down selected the teams that are going into the incubator, and this is the list of evaluators. So thank you again. If there are any evaluators that are actually online right now, we really do appreciate all of the time and effort that went through this, and the caliber of the applications was pretty high. So it also means that it was like harder to actually pick the teams that are actually going to be participating. So here's the overall stats for the teams again. So there's 20 teams, 5 countries, and 100 participants. So the teams have varying numbers of the number of team members. So it could be from 2 to like 11, which is why there's about 100 participants that will actually be participating. And here's the breakdown as well in terms of like the 2 categories. There's the high school category where there's like 7 teams, Australia with 1, New Caledonia 1, New Zealand 3, and Philippines 2. And then going to the university startup category, we have Australia 2, East Timor 1, New Caledonia 1, New Zealand 4, and Philippines 5. So here is also an animation that Eric created just like recently. So here you can see where all of the teams were sort of like spread around the Pacific region, which is why it's actually pretty good that we're doing this online. And we're going to be using all of the online tools to make sure that we are going to be more interactive and using the tools that could be used like for remote collaboration, because we're all like, scattered all over the place. So let's start then with introducing, let's see. So we start with the high school team first. And I know that not everybody is online, but okay, so my understanding is I think Methane Mavericks is unfortunately not with us, as well as Beyond Horizons, but let's see, is EIGC from Dumbea, New Caledonia online?
Yes, we're online.
Awesome.
Good afternoon.
So yeah, so
let's
what we're
start.
gonna do, what we're gonna do right now is just that each team will have like maybe a minute to basically talk about who they are, where they're from, what specific thing that they're kind of like intending to work on, and then potentially what is the idea or the technique that they're going to be focusing on. So take it away.
Okay. So good afternoon, everyone. I would like to express our team's gratitude for being selected. My name is Sabrina Toralbaguyen, and I would like to introduce our team named EIJC, consisting of 5-year 10 students, 3-year 11 students, and 1-year 12 students. This project has also been overseen by 2 of our teachers, and I would like to mention that we are a group of passionate students from James Cook International School, located in Dumbea, New Caledonia. And as students from various year levels, age ranges, and with diverse backgrounds, we bring a wide range of strengths, skills, and perspectives. This is the very first opportunity for us to participate and collaborate to an international challenge, such as this one, and we hope that our enthusiasm, creativity, and hard work pays off. And we are waiting for the validation of access to necessary technologies to better address monitoring of methane emissions, identifying their sources, including natural and anthropogenic sources, like industrial processes, agricultural practices, and energy production, and many more. And as for using specific technologies, we require advanced technologies such as drones and its access to its technology, the LIDAR, which is the light detection and ranging, which is also a satellite data from specific areas. Thank you for your attention.
Thank you so much.
Thank you.
Yeah, great, thank you. So next, I think I'll call on Kashmir Space Club. I think Cairo is around.
Yeah, I'm all here. Can we all see me?
Yes.
Cool. Hey everyone, I'm Cairo. We're from the Kashmir High Space Club in New Zealand, Christchurch. So we're made up of a few students from here. So Charlie, who's on the chat, Joel, Boyd, and yeah, myself. So we're making up a methane monitoring system for the agricultural sector, which essentially is a system for farmers to monitor their agricultural methane emissions and to help the New Zealand government to report to the IPCC. So what we're using for that is methane set data, and also for processing it neural networks. That also works along with some ground stations and other data sources like I'm not sure what you call it, sorry, but like the low-level interactions monitoring systems, which are quite expensive, but it all works in combination to make up an accurate methane map for reporting to the IPCC as well as to the local governments. So thanks, everyone.
Thank you. Okay, so the next one is CH5 from Turanga, I think Automotive College.
Hi.
Hi.
Hi, so I'm Lauren. I'm in a team with Agnes, Peyton, Indy, and Emma. We're a group of junior students, so we have 4 year 10s and 1 year 9, and we're from Automotive College in Tauranga, New Zealand. Our approach to the challenge looks at using CRDS technology to investigate the isotopic signatures from specific methane sources. So we focus on improving data collection, utilizing existing domestic flight routes, and from there it's possible to develop strategies to mitigate emissions from specific sectors. So yeah, that's pretty much it. We really look forward to being part of the incubator and getting to know everyone. So thank you.
Thanks so much. That's great. Okay, so our next, we have 2 teams from the Philippines. So let's start with the initiators. Great, we can see you.
Mabuhay and good day, everyone. I am Brian Stefano, and I'm going to be representing Team Initiators. So who are we? We are a group of 10th grade students from the University of the Philippines High School in Iloilo, Philippines. Our goal is to detect the emissions of methane gases at dam sites through the optimization of a Picaro G2508 CRDS tower. That's all, ma'am.
Thanks so much. And let's see, Usman Iftikar. We can't, can you speak louder?
Can't hear you.
We can't hear you.
Microphone use.
Yeah, unfortunately, we can't hear you. Do you think that because of your headphones?
Hello.
Oh, here we go. Yes.
Yeah.
Sorry for the technical difficulties.
No worries.
Nagkakaisang mga estudyante kontra sa methane. Kalikasan ay yaman para sa bayan. Greetings, everyone. We are the unified students by observing national and global methane emissions, also known as USBONG. We are composed of grade 10 students from the University of the Philippines High School in Iloilo, UPHSI. Our study focuses on detecting methane emissions from rice paddies with the use of drone and satellite sensors. We intend to locate these emissions by mapping the location of rice paddies throughout the Philippines using mainly satellites, aided by on-site drones. Think of it as a blind person who can see clearly. Through this study, we aim to give a clear sight of methane emissions by producing a virtual 2D map. I would also like to correct that the location is not Gimbal, but from Iloilo City. Thank you.
Yeah, sorry
All right.
about that. Yeah,
Bit of
I
a-
did change it from in the press release, but but yeah, so it's I actually love your name. For anybody who's not Filipino, Usbong is like basically report me. So it's a play on words, which is really nice. Yeah, so that's the I think the high school category. Is there anybody else that because I know Methane Mavericks and Beyond Horizons are I don't think are here, but we will learn from them next week when they're in the incubator. Yeah, I'm really impressed with everything that we've kind of like heard so far. When I was in high school, I wouldn't be doing what you're doing. So really excited to see what you come up with in the challenge. So let's see. So now, oops.
Oops.
Sorry, 1 second here. Here we go. Okay, so in terms of the university startup category, so we have 13 teams. Not all of them are
It is doing your caption, closed caption.
are here, but in any case, so let's start with Australia. We have 2 teams from Australia. And let's see if IEA or the let's see, what's the full name of IEA?
Yeah. National.
Are you online?
Hi. Hi, my name is Vu. I think it's IXI instead of IEA, isn't it?
Oh,
Is it IXI? Okay.
Yeah, it sounds more like IXI.
All right.
Hi, I'm not sure.
Yeah, we don't
bec-
see your video, but it's okay. We can hear you.
Yeah, so my name is Vu. I think our representative today might be busy. I'm Vu, a grad student from Macquarie University, Australia, working with IXI Limited. My supervisor is James Bevington. He's the head of a startup called IXI, which is short for Interplanetary Action Institute of Australia. So we are here today is to discover methods of methane detection by fingerprinting on a global scale using CubeSat. So yeah, I think that should be it.
Emmeline, you're muted.
Sorry about that. Yeah, so I was like saying that the next team, there's also a typo here. I know it's I Spy Earth. So do we have a representative?
Hi, Ian and Bertram here from East by Earth. We're South Australia. Probably not a lot of difference in terms of what we're trying to do. Our background, East by Earth, already works in dark vessel detection, looking for people who don't use radar, AIS or VMS, but still try and poach your fish, and we do that incredibly successful. We also work within the tuna industry, finding tuna, and right now we're coming in to find your methane. Our team includes my wife, the founder of the group. Bertram is head of GIS for biological sciences at Adelaide Uni. We also have Jiong Lee, who works for the Industrial AI division of University SA, and a guy by the name of Samson Hollywood, who has the looks, the brains, and the rest of us provide everything else. Again, our focus is on methane detection from space. We are here as we were getting involved with New Zealand's methane SAT program. Those details will have to come from my wife. And in terms of technology, we've currently already invested in monitoring equipment, similar to one of the first groups you spoke about, and looking at working with farms, mainly in South Australia, as a ground truth, but being able to calibrate from space, but also work with groups like the World Bank to be able to give an actual reference of methane and general carbon count that can then be counted in carbon credits and or into international and national reporting. Thank you.
Thank you so much. Okay, going to the next country, I guess, do we have a representative from East Timor? I think I saw somebody on video earlier. From the GSIG group. Yeah, I see somebody from the GSIG. But if
yes. Hello. Can you hear me?
Yes, there's an echo and I can't see your video, but as long as we can hear you. Yeah, sorry, I can't hear you at the moment right now. So I think what I'll do is I'll come back to you and let's see if we can fix the issue. How about New Caledonia, Hackabro?
Yeah, hi everybody, can you hear me?
Yes.
Yeah. Well, hi everybody. Bonjour à tous for the French speaker. We've been a bit tricked by the New Zealand time change because we thought we had 1 hour of delay, but it's 2. So I will speak instead of our team lead Thomas, but it will be the same. So I'm Cyril. I'm member of the Hackabro team. We're a team of 4 friends based in New Caledonia. We're not really a formal startup, but it's just like we all are working in different branch of the IT field, but not directly in the JS technologies. So our team is composed of 4 people. So Andy, Stoyan, Thomas, and me. So we all met a few years ago during the Ocean Hackathon here in New Caledonia, and from there we decided to compete together on similar challenges, and we are glad to have been selected for this one. So for this challenge, so our technical approach will consist of the improvement of an existing neural network we developed, so a LSTM neural network we developed for the last hackathon. So at the time it was used to predict Antarctic Sea ice pack movement. But for this challenge, we need to improve it a lot, make a new modification. So we will, for example, we would like to modify it from 2-dimensional geographical data to 3-dimensional, so in order to improve it. So yeah, that's it. We're very glad to be here, and thank you.
Thank you so much. All right, so I think I see now I see Ponzi. Can you yeah, if you unmute and see if we can hear you.
Yeah, I'm sorry for later.
Oh, great! Now we can hear you.
Can you hear me now?
Yes.
Okay. Thank you very much. My name is Ponciano da Costa Jesus. You can call me Ponci. I'm from Timor-Leste. It's very excited to join this challenge because it's like when we see this opportunity, it's like especially for specific reason. But when we try to apply it, but finally we can go. So that is like it's a wonderful opportunity for us. Here, just me and represent my team. I want to a little bit introduce about my team. I think like the ZSIZ is like one of our association based in National University of East Timor. We are focused on how to develop GIS and to address environment problem and also IT maintenance, and also how to use the technology of GIS to address emission methane contributed by gas industry and also agriculture sector in Timor-Leste. I think this is a little bit introduced from me. Thank you very much.
Thank you very much as well. All right. So let's go to the next set. So we have a set of New Zealand teams. So let's see, do we have a rep from Mapping Mavericks from Dunedin?
Yes, hello.
Oh, great. Yeah, we can hear you.
Perfect. So, so I'm Petra and this is Anna, and we make up the Methane Mapping Maverick. There's lots of alliteration there. We're both from the University of Otago and are based in Dunedin. And yeah, we're very grateful to have this opportunity and looking forward to working on our ideas. So I'll give it over to Anna to speak on our project ideas.
So we're going to fuse multiple data sources to improve the resolution of the methane data, particularly like using data sets of reactant gases in combination with the methane data sets. And we're also going to develop methods of tracking herds with machine learning. So we're going to be mainly focusing on the methane emissions by cattle in New Zealand regions.
Super cool. Great, thank you so much. So let's go to the next team. We have Methanogenesis, I guess, from Auckland.
Yeah. Hi. I'm Miguel. I'm part of Team Methanogenesis. We're a team of 12 undergraduate students from the University of Auckland in Auckland, New Zealand. The specific targets we want to investigate are waterborne methane sources like wetlands, rivers, lakes, and we're looking to use Sentinel and UAV datasets to identify targets using neural networks. Yeah, that's it for me.
Thank you.
Great.
That's great. Next, we have another group from University of Otago, from the School of Computing in Dunedin. I think Chris is around.
Yeah.
I don't see, he was, I think he was there earlier. Okay, next one is the team from Victoria University in Wellington.
Hiya.
Oh.
Yeah, so my name's Alex. I'm from Victoria University. Personally, I'm an electrical engineer. And me and my fellow teammates, Kanish, Sam, Alexa, and Lance, are really excited to be a part of the challenge and a little bit about what we are trying to achieve. We're looking at using the known methane data sources such as Triponi, GoSat, and those other ones, and Google Earth, and overlaying that on a world UI that highlights known methane points of interest such as swamps, grasslands, and facilities, to then create a data set to train a neural network-based AI to detect possible sources of methane around Earth. And yeah, thank you to Emmeline and the Space-Based team for giving us the opportunity. And yeah, we're really excited to do it. Thank you.
Awesome. Yeah, thanks so much as well. All right, so we're on our last set of teams from the Philippines, and we have EarthGang from Quezon City. Do we have a representation? Nope. Okay. Going to the next one, Nova. Do we have somebody from the Nova team? Nope. All right. How about Project AIM?
Hello.
Yes.
Okay.
Here we go. Yes, we can hear you.
Okay. Good morning, good afternoon from the Philippines. So we are the Project AIM, assessing information of methane, and we are composed of students, astronomy students, geology and electronics engineering from different part of the Philippines. So we have from Rizal Technological University, Caraga State University, and Adamson University. So we are composed of dedicated and innovative individuals with a keen focus on leveraging satellite data and IoT. So we are focused on estimating methane emission in rice paddies in a certain region in the Philippines using open source tech such as QGIS and GE. And we are glad and happy that we are chosen in this incubator program. Thank you.
Yeah, thanks so much. Great. Next one is, let's see, do we have representation from the Hubblers?
Hello, am I audible?
Yes, I can hear you. Thanks.
Okay, nice. Hello everyone. I'm delighted to introduce you to the Hubblers, a team of curious students from the University of the Philippines, Diliman. I am Francis Lansumawan, studying physics, with my teammates, Jan Rian Patino and Christoph Jan Padilla, who are both studying mechanical engineering. So our project is Project Mangita, a methane analysis network for gas identification by a tracking algorithm, which aims to differentiate different types of methane emission sources and create a visual map for public awareness. So our project essentially focuses more on data analysis and not in data collection. So we thank you for this amazing opportunity, and we are very excited to venture into this incubator program. It's a pleasure to meet all of you, and that is all.
Thank you, Francis. So I think we have our the last group. Do we have a representation from Mugen?
Hi, yes, I am Angelo from Team Mugen. I am a postgraduate student at the University of Strathclyde here in the United Kingdom, and our project is a machine learning approach to identifying and predicting weaker sources of methane emissions in the Asia Pacific region using satellite imagery. And as an inspiration for the proposal, we know that the global cooperation has extensively studied the methane emissions from major emitters and has committed to aim only a 1.5 degrees increase in global temperature from the main overarching goal of 2 degrees stated in the Paris Agreement of the United Nations Framework Convention on Climate Change. So the weaker sources are left understudied. And our proposal, it aims to develop a holistic method in identifying these methane emissions with relatively low emission rates and localized nature in the APAC region. This will combine the use of satellite data and the application of machine learning model prediction to determine the relationship between multiple parameters that set methane at an interesting rate of concentration. And also, we see that there's a sparse coverage of publicly available methane data sets in the APAC region, with Australia an exception. And a couple of factors we saw are that influenced this problem is one, the geographical setting and climate of the countries within the region, and also the spectral and spatial resolution limitation of the satellite instrument. And to aid this, we will also be performing in-situ measurements for our proposal. That's all. Thank you.
Yeah, thanks so much again. I just wanted to make sure that we didn't actually forget anybody, or if somebody has jumped in after. Here we go.
Hey, Melina, I just jumped on. I thought I was logging on early, and apparently messed up the timing.
Oh yeah,
So
there was a time change like recently, so.
I see that gets me frequently. Anyways, I'm Jay Bevington from the Interplanetary Exploration Institute, and our team is actually a combination of my startup, so the Interplanetary Exploration Institute, and Macquarie University. So I'm collaborating with Edis Seton, who's a professor there, and we have 2 graduate students, Vu and Yadvinder, who are also going to help on our project. We're Sydney-based, obviously, and our main goal at the moment is building a sensor that's actually going to help fingerprint methane through using isotopes as a signature. And as part of this, we're going to continue pushing that sensor forward, but also we want to study how having that isotopic data will help us improve on existing data sets to help fingerprint methane by its source type. And so we're really excited to be part of this, and I'm really excited actually to learn from everybody else. It was quite amazing to see all of the brilliant ideas and excellent people that have been pulled together through this challenge. So I'm looking forward mostly to learning from everybody else on the call.
Yeah, thanks, James. And same likewise here. It's really exciting to hear all of the teams actually, even just to see the teams and talk about what they're going to be trying to do. I also wanted to point out, like, so Usman Iftikar is part of our team. So he's the head of partnerships and growth for Space Base, and he's based in Melbourne. So I just wanted to introduce you. Usman, do you want to just say a few words?
Hi, everyone. And kia ora to those who are in New Zealand. Welcome. It's really great to have all of you. And I've just been listening in the background, your amazing stories and ideas. And really excited to see how we'll be able to help you over the next few months. So yeah, a bit of background about me. I am a mechanical engineer by training with some background in engineering management and particularly helping early stage startups in the space industry commercialize. So I am based in Australia, in Victoria at the moment. And I've had a few different roles. I've supported in terms of accelerators and incubators. I run a program called Catalyzer, which helps migrant entrepreneurs who are in Australia to launch their own businesses. And through that, now we've supported over 950 entrepreneurs. I've also worked with the federal government and sort of helped with the grant sort of piece as well, and have recently set up a new fund that invests in startups as well. So if you have any questions that you want to sort of ask around raising capital or interested in, kind of understanding quickly about Australia or Australian teams, very happy to help you on this journey as well. And then welcome once again. Really looking forward to working with you.
Yeah, thanks, Usman. And also for the teams, Usman is actually going to be doing at least one of the sessions as well in the incubator sometime in October, November. So look forward to that as well. So yeah, I think we're certainly ahead of time, and because that's all we have for today. But don't go away for the teams. For the general audience, again, thank you so much for being with us today. As I mentioned, this is all part of the Auckland Climate Festival as well, and there's still a lot of other activities and sessions that are happening until the end of the month. So please make sure to go to the website online and look at what other sessions are still available.